Hello everyone, my name is Saramsa Prasad Sercher and welcome to my presentation on my GoodRx drug pricing and analysis project. This project was developed as part of my DCS 625 course at Carolina University for the summer 2025 semester. Over the next few minutes, I will walk you through scraping, cleaning, visualization, and deriving insights from the data. Thank you. So, to give a brief introduction about myself, I have a background in AI and machine learning while specializing in data analytics. And to talk about the project goal, it was to extract and analyze real-time drug prices for GoodRx for 10 different types of drugs for three major cities, which are New York, Los Angeles, and Chicago. So to give the project overview, GoodRx is widely used in the US to compare drug prices from various pharmacies. It's especially valuable for people without insurance or for those looking for the best deal on medications. For this project, I focused on a set of 10 commonly prescribed drugs, looking at their prices in three major US cities, New York, Los Angeles, and Chicago, as I previously mentioned. By doing so, I am aimed to detect city level price variation and identify where consumers might find the best deals. So to talk about the tools and technologies that I have used, I used Python as my main programming language because of its wide range of libraries for web scraping, data cleaning, and visualization. For scraping, I have used Selenium as the key tool, enabling automated navigation and data extraction from dynamic GoodRx pages. Pandas and NumPy handle the cleaning and transformation stages. For visualization, I chose Plotly because it creates interactive and visually appealing charts. Finally, I used NLTK, which is Natural Language Toolkit, and WordCloud for natural language processing tasks, such as analyzing pharmacy name keywords and finding common word patterns. Here is a quick overview of my project workflow. First, in the web scraping stages, I use Selenium to set the zip code for each city, search for each drug, and capture relevant details like price, dosage, pharmacy name, coupon prices, and whether any special offers were available or not. Next, in the data cleaning stages, I standardized the price formats, mapped zip code to city names, handled missing values, and created new columns for analysis. Then the exploratory data analysis stage involved visualizing price trends, special offers, and online versus in-store pricing differences. Lastly, the NLP stage allowed me to extract insights from text data such as frequent pharmacy name keywords and bigram patterns. So in the code highlights section, some important aspects of my code include handling dynamic web content by using retries and explicit waits to ensure elements are loaded before extraction. I also incorporated polite scraping practices, which includes delay between requests to minimize the risk of being blocked by GoodRx. And in data cleaning, I focused on converting all prices to numerical formats, extracting quantities from text fields, and filtering out incomplete or irrelevant records for easier analysis. So now I'm in the exploratory data analysis section. For the key visualization, I have decided to include this bar chart, which compares the average prices of commonly prescribed drugs across uh, listed cities, which are Chicago, Los Angeles, and New York. We can see that certain drugs like simvastatin shows consistently higher prices across all three cities, while other drugs like hydrochlorothiazide remains relatively low. And what does this indicate is that this helps to identify both geographic price stability and variation as well. So under the EDA section, for key visualization 2, I have mentioned price variation by quantity and drug. For this, I have used scatter plot, which examines how drug prices vary based on quantity, which are 30, 60, or 90 units across different drugs. While some drugs maintain consistent pricing regardless of quantity, Others, particularly those at 90 units, shows a higher range of prices, suggesting that bulk purchasing does not always guarantee proportional savings. So for the final visualization for the EDA section, I have decided to show this bubble chart which compares standard coupon prices against special coupon prices for each drug. Most points lie below the diagonal line, indicating that the special coupons often result in reduced prices. Larger bubbles like simvastatin and omeprazole show significant savings potential, making them strong candidates for targeted cost reduction strategies. So, as per the project requirement, we were required to formulate 5 hypotheses to guide the analysis. So the first hypothesis, I looked at the most common words in pharmacy names. Not surprisingly, pharmacy and CVS were amongst the most dominant, reflecting both generic and brand-specific naming trends. For the second hypothesis, I identified which drugs had the highest number of special offers. So as per my result, I was able to find atorvastatin, a cholesterol-lowering drug, and metformin for diabetes were at the top, which might be likely due to their high demands and generic availability. And for the third hypothesis, I explored which cities had the most frequent special offers. The leaders were New York, followed by Chicago and Los Angeles, which may be driven by market size and pharmacy competition. And for the fourth, I examined the most common bigrams in drugs and pharmacy name. As expected, brand name followed by pharmacy were the most frequent naming trend. And finally, for the fifth hypothesis, I compared online versus offline special offers. The results showed that offline pharmacy provided more special offers, possibly to attract foot traffic and compete locally. These findings help illustrate pricing trends and market competition and promotional strategies within the GoodRx dataset. So, for the results and insights from this analysis, I found that generic medication were more likely to be discounted, and certain cities consistently had lower prices for specific drugs. The data also showed that online pharmacies sometimes offered better deals, but these differences were not always dramatic. These insights can be valuable not just for consumers but also for healthcare providers, and even policy researchers who wants to understand pricing dynamics. Throughout the implementation of projects, some of the challenges and limitations that I had faced are one of the main challenges being that GoodRx uses dynamic JavaScript rendered content, which meant that the coupon details and prices didn't always load instantly. I addressed this by adding explicit waits and retries, but even then some offers were inconsistent. Another limitation is that this is a small dataset, only 10 drugs and 3 cities, so the insights are more of a demonstration than a comprehensive market study. So the steps that can be taken for future improvements are, if I were to expand this project, I would scrape more drugs and cities to get a larger data set. I would also automate the process to run a schedule so the data stays up to date frequently. Finally, I would like to connect this to a live dashboard in Power BI or Tableau, allowing user to filter by city, drug, or pharmacy in real time. So in conclusion, this project demonstrates how web scraping, when combined with analytical techniques, can uncover actionable insights from publicly available data. As you can see, I was able to take a real-world website, extract structured data, clean it, analyze it, and present findings visually and through NLP methods. I look forward to scaling this work and explore how these techniques can contribute to healthcare analytics more broadly. And thank you for your time, and I'll now be happy to answer any questions. And lastly, I would like to mention, for anyone interested in reviewing the complete project, including the web scraping scripts, data cleaning steps, exploratory data analysis, and NLP-based hypothesis testing. I have made the code and dataset available on my GitHub repository. You can visit the links shown on the slide to explore the source code, documentation, and instruction to replicate the project. Before we conclude, I would like to take a moment to express my sincere gratitude to Professor Nutricia Jones for her guidance, feedback, and support throughout this project. Her insights have been invaluable in shaping both my approach and my understanding of the concepts we applied. I also like to thank Carolina University for providing the platform and resources to explore and complete this project. And thank you for your time and attention.